Hello, 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 friend. Hello, hello, friend. Hello, friend. Hello, friend. Welcome to this course, A to Z Complete GIS. So, we are in the machine learning sections, and this is the lecture 2 of the machine learning. And today we will learn logistic regression. So, let's go and try to understand what is logistic regression, and after then, some definition and other things. We are going to try to understand the code structure of this and what is the logistic. And we will try to uh, do some work on real data. So start with the logistic regression. The first introduction to the logistic regression. What is the logistic regression? Logistic regression is a supervised machine learning algorithm. What is the supervised machine learning? I have already told you in lecture first. When the input and output data you have, so that's the supervised, and that's algorithm, that is a logistic algorithm used for classification problem. It predicts categories, classes instead of continuous values. Example: student pass or fail. Pass is 1, fail is 0. Email spam detection, spam is 1, not spam is 0. Disease prediction, disease is 1, no disease is 0. Loan approval, approved 1, rejected 0. That's the problem we have deal with the this logistic regression. This is not a continuous like 1, 2, 3, 4, 5. Okay, why not linear regression? Suppose we want to predict whether a student will pass or fail. Study hours 2 hours, 4 hours, 6 hours, 8 hours. If he study 2 hours, this will be fail. 4 hours he will be fail, and 6 hours he will be pass, and 8 hours he will be pass. Then how can we use this through linear regression? Not possible. So that's come to the logistic regression concept. So if we apply a linear regression on this, y is equal to mx plus c. So predict 1 hour is equal to minus 0.5, 5 is equal to 0.7, 1.8. Predicted value is this. Probability cannot be less than 0. This is the probability phase of pass or fail is the probability. If he read almost 2 hours, then he will be fail. It's a probability 0. And if a pass, then probability 1. The maximum probability is 1 and minimum probability is 0. But from the linear regression, this will be minus, this will be more than 1. This is not possible. So probability cannot be less than 0, probability cannot be greater than 1. Therefore linear regression is not suitable for classification of this type. Okay, so solution linear regression. Solution for the logistic regression converts to output into a probability between 0 and 1, range 0 from 1. So this is the nothing but a probability. Okay, so example probability of the class: 0.10 is fail, 0.35 is a fail, and 0.75 is the 1, and 0.95 is the pass 1. Now a famous function is work in the this logistic regression. That function is called the sigmoid function. The heart of logistic regression is the sigmoid function. This is the heart of the logistic regression. Every algorithm is done by this equation. Equation is a p, y is equal to 1 is equal to 1 upon e 1 plus e to the power minus z, where p is a probability, e is the Euler's constant, it is a 2.718, z is linear equation, and z is equal to b naught plus b1 x. So sigmoid curve probability is this, lower side is this, higher side is this. So this is a sigmoid curve. Important points: the sigmoid curve always gives output between 0 and 1. Okay, that's the range because it's a probability. So that's why the sigmoid function is a, remember that this equation, and this range is between 0 to 1. Okay, working of logistic regression. Step 1: calculate z is equal to p0 p1 plus b1x. First calculate the z. Step 2: apply sigmoid function, put this value of the z in this, and you know the e is a constant, and this constant is called the, here I have already told you, Euler's constant 2.718. Okay, apply threshold. Usually threshold is 0.5 and probability is less than or equal to threshold for this. Okay, upon this 1 plus this and then this, uh 0.5 is class 1, 0 point less than is 0. Okay, threshold value you have decided. Okay, above zero point 0.5 is 1, it's mean that true, and below zero point 0.5 is class 0, remember false. Student exam prediction: student 2 hours, 0, 0, 0, 5 and 7 hours if you study, student doesn't pass. Suppose the model is z is equal to minus 4 plus x for 6 is equal to 2. Step 2, put this value, and p is equal to 0.88 is greater than 0.5, therefore pass. So odds, if the odds number is taken, your odds represent the chances of success compared to the failure. Formula odds is equal to p upon 1 minus p. You know the, if you know the probability function, then you can know. Okay, example probability is p is equal to 0.8, then odds is equal to 0.8 upon 2 is equal to 4, and this meaning success is 4 times more likely than failure. And this is the logic of the logistic regression. So again, a function is very important function, that is logit function. Logistic regression actually works on log odds. Formula logit, natural log p upon 1 minus p. This transfer probability into linear regression. Complete logistic regression equation is equal to uh, natural log p upon 1 minus p, b0 plus b1 x1 b2 x2 up to the bn x1, where b0 intercept, b1 b2 is a coefficient, x1 x2 the features. Okay, decision boundary align, this separates classes. Example, 0 boundary class 1. So everything on one side is class 0, everything on the other side is the class 1. You know the class 0 is a true false, and class 1 is a your true value. Types of the logistic regression: binary logistic regression, two classes only. Example, pass or fail, yes or no, disease, no disease. Multinomial, come to the multinomial logistic regression, more than two classes. Example, cat, dog, horse. Then what will you do? Then ordinary logistic regression, ordered, poor, average, good, excellent. Cost function is also logistic regression. Linear regression use MSE, but logistic regression use log loss. Formula cost is minus 1 upon e summation y log p plus 1 minus log 1 minus p. Purpose, minimize prediction error. Okay. Maximum likelihood estimation, Emily. So logistic regression does not use ordinary least squares. Instead, it uses maximum likelihood estimation. Goal, find a coefficient that maximizes the probability of observed data. Simple meaning, find the best line that gives the highest prediction accuracy. Confusion matrix, suppose actual is predicted, actual and predicted. This one, you know the confusion matrix. Suppose one is 1, predicted 1 is 0, 0 is 1, and then you are predicted, and this is the actual one. So confusion matrix, actual is true, true predicted, false fn, and actual predicted is this one. So this is the way for the matrix for the actual and predicted. Evaluates matrix is here the accuracy at tp plus tn upon total, represent tp upon tp upon fp, and recall is equal to tp upon tp plus fn. Score is equal to precision recall 2 into precision plus recall. Roc curve is very important in this logistic regression. Receiver operating characteristic mean that TPR here is this and FPR is here this. You know the TPR and FPR? You know? Okay, I will tell you later what is the TPR and FPR. Okay, so this is the receiver operating characteristic, and I'm not going in a deep in this way, so that's why the bus I'm telling where this is a very important function and how this will work. AUC, area under curve, performance 0.5, 0.6, failure good, you can this categorize. So advantage of the logistic regression is easy to understand, fast training gives probabilities, fast training work well for binary classification, less computational power required. Disadvantage, assumes linear relationship in log odds and sensitive to outliers, and you have to very much about the outlier and inliers, because if this is present then your value must be give you a wrong prediction. Okay, so next is not suitable for highly complex patterns, and this one is next is the your not suitable for highly complex pattern. Deep learning may perform better on large complex data set. Real world application, healthcare, disease prediction, banking, loan approval, marketing, customer purpose prediction, and email services, spam detection. The use of the in your Gmail, this type of the algorithm has been used. Okay. Uh, uh, Sorry for this. And whether rain or no rain, weather protection, hydrogeology, groundwater contamination protection, aquifer suitability mapping, ground water potential zone classification. So the workflow for the logistic regression: collect data, data cleaning for the outlier and inlier, and train test split, train logistic model, predict probability, apply threshold value, classification, model equation, deployment, and etc. Interview question is the most important. What type of the interview question can be asked in this? So the interview question is asked in this. The first is logistic regression used for classification? Whatever the use, it is used for a classification. Output range of sigma function 0 to 1. Default threshold value, you what will you check? 0.5. Above 0.5 it is a true value, below the 1 value. Okay. Now cost function is log loss function, and optimization and maximum likelihood estimation. Main advantage metrics: accuracy, precision, recall, FN score, RSC, and AOC. And the one line summary, if you want this type of this, then logistic regression is a supervised machine learning classification algorithm that uses the sigmoid function to convert a linear equation into probabilities between 0 and 1, enabling classification into different categories. So this is the overall a brief summary of your logistic regression which I have told you. Now I will go to the here this practical part, then this will be more clear. The first, what will you do? You have to go your system and here search the anaconda and click on this, or directly go jump to the Jupyter. Okay, from here. So I have already searched here this is the my anaconda GUI interface. Here I am select the launch Jupyter notebook and I have already launched this. Okay, this is the my Jupyter notebook. Okay, this is my Jupyter notebook and my file is on the in this one, and this is the logistic regression implementation. Okay, this is opening. Just wait for 2 to 3 minutes. Okay, now class 10, class logistic regression, lecture 2, and in machine learning by Seemab Akhtar. Okay, I've already told you for this machine learning purpose you have to set your anaconda environment, and for this I have already set. And from here this is the my anaconda environment, then this will be go. Otherwise you will know when you will run this in normally, then the error will come. Okay, then this must be error will come and you will in trouble. And how to set the your environment? What is the environment? I have already in a class explained in class 9. So go to the my previous lecture and try to understand this thing. Okay, the first things you have to copy these libraries and import this. Okay, pandas, numpy, scikit-learn, and penpal. This is the machine learning this thing. And this you have to train test split, and these are the libraries you have to import. Pickle and this type of the libraries you have to import. And what is the work of this? Try to go to the Google and search it. It's your homework. Okay, now this will be, and this is a sign for the code is running, so just wait. And when this will run, then we will do. Okay, see user template this in devoting environment. It means this from pandas profiling import profile reader. This is the very important panda profiling. For this you have to set your environment, and how to set your environment I have already told you. Okay, next is next code is you have to call this data set, and I'm calling this data set from this web address stp this. You can just copy and see. This is taken from here this website. When you'll copy it, then you'll see the website name. Oh sorry, just see, this is a data set. Okay, this is on drive. Okay, Now I'm going to fetch it, and in and from the pandas you are in the frame, data frame. So just I'm doing this thing. Okay, now this has been done. Now go to a df. Okay, see, there are 768 rows and 9 columns, and these are data pregnancies, glucose, blood pressure, and this is a health monitoring data. And insulin, BMI, database, age, and outcomes is 1 and 0. Already is given this logistic regression outcome. Okay. Next is the profile report. Profile report. This the DF and this thing. It is opening. That's the beauty of the pandas profiling. Okay, that is running. 84, 85%. Some data say 90, 94, 93, 100%. Generate report structure. It is generating the report structure. Okay, now render to HTML profile and overview. You can see articles 9, and this high correlation of this age is highly overall correlated with the prognosis, skin thickness, insulin prognosis with age, skin thickness is highly overall correlated with insulin. Prognosis has 1114.05 for this thing. Okay, and this is the zero pegnasis has a one zeros blood pressure thinking, and this is the variables of these things. You can see zeros maximum, and this is the beautiful way the panda by the pandas profiling. So I'm going to little bit slowly. Okay, now is there anyone not come in my chat box? I'm again written hi everyone. No one is coming, so don't wait. Anyway, so blood pressure real number and this thing skin thickness. So blood pressure, for blood pressure distinct 47 and this missing and minimum 0 and this. So insulin profile and the BMI profile, diabetes predictions, real number, age related to distinct 52, minimum this one minimum age is 21, and this is the way. Okay, and missing values of this pangases, so the missing values in this, and you can see. Okay, sample first rows, last rows, you can see. Okay, and this is the way. Now, last rows and this way profiling. You're going to the profiling. I'm just in the productions. So see the Y data production software version white profiling. When you will click this and see the these things and the download configuration and see variables is this, but select the column glucose and blood pressure. See, select any, just it, this will give you the age. Okay, everything you will get this in correlation tables and this heat map through correlation you can see it. Anyway, I'm going to the next column, and this is the way for this. So next is correlated these things and see. Okay, this is the thing. uh Now I'm going to the box plot. Okay, I'm correlating the different things: skin thickness, skin thickness, insulin, and the now do it these things, and what will happen? We'll see here. Now this is generating the different profiling correlation of this different row and column. Okay, now you can see this all artic alerts, and this you can see here. Okay, high correlation and this things you can see just the previous. Okay, now what will you do? I'm just going to the plot a box plot in between different your disease and this. Just give me the 1 minute. Access the plot. This will be showing here. Okay. Okay. No problem. Anyway, I'm going to check it why this is not plotting this way. This, but this can be. Anyway, go to the next. Mm, just give me 2 to 3 minutes. I'm just sort out this one. Why this is not working? Okay, let's do it. These things. I think this will work. Mm. Okay, now this is work. This is work. Okay, now again I'm just decreasing the figure size 5 into 5. See now this is work. Okay, 5 into 5 not 5 into 10 into 5. Okay, then what will happen? See, okay, now it is okay. Now it is okay. 10 into 5, you can see different disease, and y-axis you can see this number. Okay, how many persons are affected, outcomes 0 to 1. Either come to the 0. Okay, and there is no outliers. The in data set you have to clean it the first, so this will be work. Now next is I have told you. And so the box plus, what is the showing the box plot here? The per mustache is showing the your bus. Basically this is the box and whiskers plot. Okay, so the upper mustache is showing these things. You outlier part is the maximum value, so the maximum, this is the median value. Okay, it is showing you. Next is this things. What will you do? The see what will happen to the in this things. I will show you. See the this is the pregnancy and the outcomes is 0 1 and this. Okay, now again plot this. If this subplots figure and axis between df new and this one. Okay, see perfect plot between this, and you can see these things, outcome diagesis, and you see the outcome is 0 these things. Okay, now I will take the 5 minutes break and then we will continue. Okay, come to the class now. Next is this. We have seen the box plot for the different rows of this data set. With this, now what will you do? Now we will see the some new features and try to correlate with this. Okay, now how to remove the outlier from the data? That's the code for this, and I will show you. And this is the code for the removing the outlier because it's a very sensitive about the outliers. Okay, now see the new data set and correlate with your old data set, and you will see. See, outlier is still present in your data set. So what can you do again? mm, Still less than no. Okay, now again run this pandas profiling and see. Just running. Okay, now you can see the all things and you can just see the values. So BL try to the this outlier, and again when the outliers are done, then you have to go for this. So tables, heat maps, easier auto correlation in this thing. So you can see here now again the df new data. Oh my. Okay, see new outcomes, and you will see the new outcomes. See the new outcome this. Okay, see. uh, I'm showing you to how to remove the outliers and without affecting your data set, and how to handle with these things. uh, then this will be because your sigmoidal function is very affected to your outliers. So see the if you handle with the this data set, then the see the still the outlier is present, but you see the different of this. Okay, and this is the plot between your thing scaled. Now go to the scale these things. Now BIF scores you can see. And now I'm going to train the data and test the data and see the beauty of this code. Xtrain array is this. Xtest array is this. Okay, logistic regression done, and activate your logistic regression profile. Okay, now come to this. Okay, okay, parameter is done. Now do it this. Name log r is not defined. I think something is missing here. Log r is not defined. Where is the log r? We have to see. Okay, I'm going to check this one. What happened to this? Just wait, I'm trying to fix it. Okay, I have written this thing. Now this is okay. Now check it. Now, okay. This the problem is here. Log R is not defined. I think how I can miss it this thing. So anyway, I will check it. Log R is not defined. I'm checking the fitting values. Okay. It means that the logr is not fit. So when a successfully model will train, then classes attribute will be created. So first I have to fit this one, then check it what will happen. Now fit. Okay. Now do it this one. Okay, now array 0 1. Okay, now this can be work because it is already fitted. Now see what will happen. Now it is okay. Now logr predict is working. Okay, see here. Now do this one. Actually, the now it is working. Okay, now y test. Check it, and this is the outcome 0 and 1. So now do what will you do? Log r. Okay, 102. Log sublinear. 1. Okay, now arrays come. Now create a confusion matrix. and the model and this. Now AUC, ROC. Okay. Now ROC this, ROC curve area this one, and ROC is this. So false positive rate, true positive rate, and this is the receiver operating characteristics. And see these things. So this is the overall for your logistic regression. So task is this, and do according to you approve. And I have told you things, and run the all code and read these things, and try to understand the definition and terms. And so this is the end for the today class, day 10 for logistic regression, and we will meet in day 11 class with new feature of the machine learning. So thank you so much for uh, joining this class. Okay, bye bye. Thank you.